Hello everybody and welcome back to another Blender Made Easy tutorial. Today we're going to be using Mantaflow to create a fluid simulation. Mantaflow is a new way to simulate fluid and smoke, and it looks really good and you can create some very realistic simulations. To actually use Mantaflow, you need to download the beta version, which is 2.82 alpha, and you can get there by going to blender.org, clicking on this blue download button, and scroll down till you see Go Experimental. Go ahead and click on that. It will take you to this page and you will see experimental branches right here. Click on this and you will see the Mantaflow branch right there. Go ahead and download that. Once you have that folder downloaded and extracted, you will be ready to go. So here we are in the version 2.82 alpha, and this is the Mantaflow branch, and we'll be creating this simulation right here. To get started, we need to scale up our cube. This is going to be our domain for our scene. So I'm going to scale it up a little bit, then I'll press S and X and scale it along the X so it's a little bit longer. And then I will just drag it up so it's sitting right on the grid floor. What I want for this animation is the water to be emitted right around this corner, hit this wall, slide down, and create a big circle of fluid. To do this, we're going to be adding in a circle. So I'll add in a circle. Then I'll press Z and go into wireframe so we can see what we're doing. Go into edit mode and then press F to fill in a face. Now that we've done that, let's position this in the right corner. So I'll scale it down a little bit, R to rotate, and then I'll just place it somewhere around here or so at this sort of angle so the fluid will get emitted and hit this side wall. I also want to make this simulation a little bit more interesting, so we'll add in a cube in the middle of our scene to be a collision. So to do that, I'll just press Shift A and add in a cube. Scale it down a little bit and just place it right in the middle of our scene. Now that we have all of our objects, let's go ahead and start working with Mantaflow. Let's go ahead and select our domain first. I'll go over to the Physics tab, and you'll notice right away there is no smoke. That is because the fluid and the smoke simulation are built into the fluid. So if I click on this and set the type over to domain, you will see the domain type is currently set to gas. This is for smoke, and then we can see there's also a liquid one right here. Go ahead and change it over to liquid. I am going to be doing a smoke and fire simulation in the future, so make sure you hit subscribe to be notified when that comes out. Now let's go ahead and select our cube in the middle. I'll click on fluid and set the type over to effector. The effector type we can change over to collision, which it already is, which is good, and that means that this will collide with our fluid. The surface thickness right here controls where the boundaries are on our cube. So if this was up a little bit, like a 0.06, it'll probably be around here, and the higher you go, the higher the bounding box of our cube will be. Since I want it to be really close, I'm going to be setting it to 0, which that should be perfectly fine. Then for our inflow object, which is this circle, I'm going to go over to fluid and set the type to flow. Now currently it's using the smoke flow as the type. We don't want that, we want liquid, so make sure you change it over to liquid. The flow behavior. This means that if it's set to geometry, it'll just be this circle and it will just fall straight down. If we set this to inflow, that means it will constantly add fluid to our scene, and that is what we want. Underneath the flow source, we also have the same value here, surface thickness. So if I turn that up, more fluid will be emitted into our scene, but at 0, it will just be the size of our circle, and that is what we want. For the initial velocity, I'm going to be setting that to on, and I'm going to set the X, which is this value here, up to a value of 3. So that means it will shoot out and end up right around here and then crash onto the ground. I might want to turn this up a little bit. Let's go 3.5. I think that will work just a little bit better. And another thing that I want to do with this inflow object is I want to animate this flow value. So at around 40 frames in, I want this to stop emitting fluid into our scene. So what I'm going to do is go over to frame 40, hover my mouse over this checkbox, and then hit I. You can also click that little button on the side and that will add in a keyframe. Next, go to frame 41, uncheck this, and then click that little button, and that will add in another keyframe. So basically, it's going to emit fluid all the way up to frame 40, and once it hits 41, it'll stop emitting fluid into our scene. Now let's get into the domain settings. So I'm going to select my domain, and here we can see the base resolution is 64. For this animation, I'm going to go with 128, and this times scale value here. I've noticed when working with Mantaflow, it's very fast, so what I'm going to do to slow it down a little bit is I'm going to set this value to 0.6. Underneath that, we have a liquid panel here, and this is for the flip particles. What this will do is it will enable us to have particles that are colliding with the cube and that are floating on top, and it will look pretty good. Now there are a lot of values right here, and I'm still learning exactly what these do. In the future, we will be creating more advanced tutorials using Mantaflow, so make sure you subscribe to be notified of those. Underneath that panel, we have the mesh panel, and this is where we will be adding fluid into our scene, so make sure you turn that on. We have a value here called upres factor, and this basically takes this base resolution and multiplies it. So currently it's set to 2, so the base resolution of the mesh will be 256, and that is a pretty good base resolution. The reason why there are 2 values here for the mesh and then for the base resolution here, basically it's because you can have different values for mesh or particles. If I open up the particle tab, we can enable spray, foam, or bubbles. For this tutorial, we will just be using this flip particles, but as you can see here, there's also an upres factor. So if you want more particles or less particles, you can set that here. We also have a cache folder, and I'm going to be setting a custom cache, so make sure you click on that little button there and navigate to where you want to save your baking. We can also set the end frame here, and for this tutorial we're going to go with 120 frames, that should be perfectly fine. And then for the end frame down here, I will also set this to 120. When baking in Mantaflow, you need to do 2 different bakes. One is for the domain, and you can see that here, it's bake data, and then another one is for the mesh down here, so you can bake in the mesh. We need to bake this one in first before we can bake in the mesh, so let's go ahead and do that. I'm going to click on Bake Data, and you can see it's starting to bake down here. Now, a really cool feature in Mantaflow is if I stop the baking, you will notice an option for Resume. This will enable you to resume the baking. This is very, very good. I'm so glad that they added this in, and I wish this was in Blender already. This is very useful because if you have a 50 frame long animation and you realize it's too short and you want to extend it, all you have to do is scroll down to the end frame, put that in here, and then you can just click resume and it will resume baking. You don't have to restart, which is huge. So what we're going to do now is I'm going to click resume, and once this is done baking, we will bake in the mesh. Alright, the baking is done, and now if we play our simulation, this is what it looks like. Now the particles are going straight down, and I would rather them be going out this way, but I think it's fine and this should look pretty good. And as you can see, the particles do look really good. There's a lot of motion. The cube is interacting with the particles, and it looks really good. So now what we're going to do is scroll down over to the mesh and then bake in the mesh right here. So make sure the upres factor is a value of 2. Then all you have to do is bake in. Now I should have done this before I baked in the first bake right here. We need to save our project. This is an experimental build, and so Blender has crashed on me multiple times while trying to record this tutorial, so make sure you press Ctrl S and you save your Blender file. I'm going to call it Mantaflow tutorial and then click Save Blender File. Now that I've done that, I'm going to go ahead and click Bake Mesh. Alright, the baking is done, and now we can take a look at our fluid simulation, and as you can see, it looks pretty good. Now the next thing that we're going to do is apply a icosphere to the particles so we can actually see them in the rendered view. To do this, I'm going to press Shift A and add in an icosphere. Now before you do anything else, open up this tab here and make sure the subdivisions is set to 1. Because there is going to be a lot of particles, the less geometry will make it so that it renders faster and it doesn't slow down. I'm going to scale this icosphere down a little bit and move it over to the right. Somewhere around there should be pretty good. Then I'll select my domain, go over to the Particles tab, and you'll see a Flip Particles particle system here. Open up the render, set this as Render as Object, and then select the icosphere in the Instant Object. Now it is slowing down quite a bit, so what I'm going to do is just turn off the particles in this tab here. Now I have done a test render with this turned off to see if it would render in the rendered view, and it doesn't. So make sure before you render, you turn this back on in the viewport so you can actually see it in the render. Now that we've done that, let's go ahead and right click and go Shade Smooth on our fluid to smooth out the edges. And now let's add in a plane and an HDR. So I'm going to press Shift C to snap my cursor to the center. Then I'll press Shift A and add in a plane. I'll scale up the plane till it's pretty big. Now that we've done that, let's go ahead and add in an HDR for the lighting, and this is an HDR off of HDR Haven, and that is linked down in the description. I'm going to go Environment Texture, Open. Once you have found your HDR, go ahead and select it and go Open Image. For the strength, I'm going to go with a value of 0.6, that's pretty good. And one more thing that I'll be adding is a lamp to our scene. So I'm going to select my default lamp, go over to the lamp settings, and change it over to a sun lamp. For the strength of this, let's go with a value of 2, and then underneath the shadow, let's turn on Contact Shadows. Rotate it whichever way that you want in your scene, that should look pretty good. Now the last thing we need to do before we render out our animation is we need to set some materials. For the fluid, I'm going to go over to the Material tab, and it should already have a default material, which it does. Underneath the transmission, I'm going to turn that all the way up to 1, and the IOR I'm going to set to 1.333. IOR stands for Index of Refraction, and that's basically how light passes through the water and distorts it, and the IOR of water is 1.333. Also, make sure you set the roughness down to 0 and come down to the blend mode and set it to alpha blend. Then of course turn on screen space refraction and turn off show backface. Doing this enables us to make a transparent material in Eevee. Then of course we need to go back over to the render tab, turn on screen space reflections, and then turn on refraction in that panel. Now if we press Z and go into rendered view, we still can't see it, and that's because we need to go over to the object panel and change it from display as wire to display as solid. And there we go, we can see it in our scene. In older versions of Mantaflow, this was not possible, it would always display as wire, but they seem to fix that in the latest patch. Next, select your cube, go over to the Material tab, and I'll give this just a blue color material. This should be perfectly fine somewhere around there. And for our circle, I don't want to see this in the rendered view, so what I'm going to do is click on this button here, turn on the camera icon, and then just turn it off in the rendered view, and I'll also turn it off in the viewport. And there we go. Now we are ready to render, so I'm just going to place the camera right about here. Then I'll hit Control, Alt, and 0 on my number pad to snap the camera to view. Then select it, move it into place, somewhere around there should look pretty good. And let's just scroll through here and make sure it all looks good, which it does. Not too bad. Now before I render, we do need to enable the particles again, so I'm going to select my domain, go over to the particle tab, and turn it back on. And if I press Z and go into wireframe, we can see there is a lot of particles, and that should look pretty good in the rendered view. I forgot to enable the material for the ecosphere, so go ahead and select that, go over to the material, and click New. And for this material, I'll turn the roughness down to a value of 0.1, and the transmission, I'll turn that up just a little bit, and then the IOR, I'll turn it to 1.333. And then we need to set the blend mode to alpha blend and turn on screen space refraction. I've noticed while looking at this in the rendered view that the particles, they're not really showing up. Now I think the reason for this is because show backface is turned off, and I turned that off while we were creating the material. If I turn this back on, we can see a lot more particles in our scene. Now we do get that weird artifact on the side of the fluid right there. Now to fix that, we can go backface culling. Once we turn that on, we can see that is gone, and now we can still see the particles without those weird artifacts in the fluid. So now with those material settings in place, we can go ahead and render this again. Now that we've done that, we are ready to render, so let's go over to the output settings and set a folder right here for our frames to go into. I'm going to click on this button here, navigate to where I want to save my frames, right here. The reason we're going to be rendering it into frames is because we can sequence it out later, and this enables us to stop the render anytime. If overwrite is unchecked, that means that it will not overwrite the images. So let's say we rendered 30 frames and then we need to stop the render for some reason. If overwrite's unchecked, it will resume at 31 and continue on. I'm going to save my project one more time, then go up to render and click on render animation. A new window will pop up, and now it will start to render our frames. Alright, the render is done, and to view it, we can go ahead and exit out of this window, go up to render and click on view animation. Once we do this, a new window will pop up and we'll be able to see our render. And as you can see, it does look pretty good. The fluid looks pretty realistic, the particles are floating all around, and it looks pretty nice. Now, if you want more particles in your scene, all you have to do is go over to the physics tab with the domain selected, scroll down to the liquid, and turn up the particle sampling. The higher you go with this number, the more particles will be added to your scene. So there you go, guys. That is how you create a Mantaflow simulation. If you enjoyed, make sure you leave a like and comment down below what you want me to create a tutorial on next. If you want to learn how to sequence your frames into an animation, there's a video for that in the description below. Thanks again for watching, and I'll see you guys in the next tutorial.